You should always start by referencing your design. For most projects, you should have a design provided by your designer, estimator, sales representative, or directly from Amatis Controls. Your design should include product placement, spec sheets, and wiring diagrams. Let's walk through an example design prepared by the Amatis team. In this example, we're reviewing a floor in a large office building. There are 5 unique control zones in this space. These zones are commissioned digitally after installation using the Amatis App. Let's focus first on the open office area. The design begins with the placement of red circles representing the occupancy detection range of Amatis sensors. Once these circles have been placed and adequate coverage of the space is ensured, sensors are located at the center of each circle. To maintain an easy-to-read design, the circles are then removed before the design is completed. You can see that care is given during the design to locate the sensors. It is important during installation to locate your sensors as close to the placement indicated on this design as possible. Now we'll show the sensor 2s across the rest of the space. Next, note where fixture controls are placed. The Amatis system has 2 types of fixture controls: smart drivers and advanced load controllers. Smart drivers are most commonly used in fixtures where you're retrofitting a fluorescent tube and ballast to LED. In this example, we've placed 2 smart drivers in the stairway. Advanced load controllers are used in all other instances for controlling individual fixtures up to complete circuits. With each smart driver and advanced load controller, we include a shaded blue region which defines the fixture or fixtures controlled by that device. In some cases, the pre-existing circuitry will need to be modified to accommodate the newly proposed lighting zones. Let's talk about how that would be done in the open office space of this example. The original circuit directed power to every fixture in the open office space, with power entering the circuit near the lower left fixture. This circuit will need to be altered to enable 4 distinct zones for each of the advanced load controllers being installed in this space. To create these zones, the circuit will need to be broken into these locations and re-established as shown here. Next, the new lighting zone circuits will be established by connecting necessary fixtures and running unswitched power to the start of each zone, as shown here. The advanced load controller that is controlling each of these zones is to be wired in at the start of each of these newly defined zones. Unswitched power should be entering the advanced load controller, and only the fixtures being controlled by the advanced load controller should be on the switched power coming from the advanced load controller. Any fixtures that are 0 to 10 volt dimmable should also be connected to the advanced load controller's 0 to 10 volt output. Please keep in mind, your design will not define how you need to change the circuit, only that the blue zones will represent the fixtures controlled with the switched power from the advanced load controller or smart driver. It is up to you to define these circuits. Let's now look to the other areas of this example. In this zone, a conference room, each fixture has an advanced load controller, providing per fixture control and the ability to customize each fixture. This allows occupants greater ability to customize their room's light level, with each fixture being independently controlled by an advanced load controller. This customization will be discussed later in the commissioning training. Next, let's look at the bathrooms. You can see that there is a single advanced load controller controlling each bathroom. It has a sensor 2 located near the doorway to detect occupants entering the bathroom. In this example, we have also placed several sensor 1s near the bathroom stalls. These sensors communicate occupancy wirelessly to the advanced load controller and help ensure that the lights don't turn off when someone might be in a stall. These sensors should be placed directly over the stall wall so that one sensor can detect motion in the 2 stalls on either side of the wall. Also note, these sensors require low voltage power, so between the 2 bathrooms we have also placed a power converter. This power converter should be provided with unswitched power, and the low voltage output should be routed to each of the sensor 1s in the area. At this point, we'll add back in the smart drivers, advanced load controllers, and sensors in the stairway and office spaces. You now know that the shaded blue region represents the switched power coming from the fixture control device in that zone, and that the sensors should be placed as close to their design placement as possible. Finally, the switches are placed in the design for areas requiring switch control, along with the Amatis border router, known as Amber for short.